this is this is what we should call the SFF panel, but really it's the Opinionated Experts panel. We've done this for about 5 years now, started as a BOF, and we've been running it now as a general talk because we want it recorded so that there's evidence of our misdeeds. So, and today we're going to talk about all sorts of different things and how we have wronged you. And by the way, this is audience participation, so we expect you guys to give us questions. And basically, you have about an hour to yell at us about what wrongs we have done in SFF and other places. So,
and we will be walking around with a mic, so there won't be any need for question repeating.
Exactly. Okay, so who are the three of us? Well, Mike, do you guys want to introduce yourselves? Go ahead.
Go ahead, John. Oh, okay. John Geldman, Kioxia, SNIA board member, ex-NVMe board member, participant in most standards groups that you can probably think of that relate to storage, including security and PCIe and JEDEC and lots more.
Mike Allison, Samsung, board, NVMe board, chair of the errata task group, OCP steering committee, and just like everybody else, I go to all the other standards meetings as well.
All the other acronyms. And I am Anthony Constantine. I'm the distinguished member of the technical staff at Micron. I am the co-chair of the SFF technical working group, where a lot of the form factor and connectors and cables and transceivers come out of. I'm also a SNIA board member. Okay, so a couple quick slides and then we'll kind of get into it. So what does SFF actually do? SFF, by the way, means SFF. We don't have an acronym anymore, and I have to keep explaining this even though Wikipedia says there is something, but so. But in any case, quick note on what we do. We are 77 companies. This number has fluctuated a bit, but we are actually growing still. We have over 150 plus specs. I think we're hovering at like 155 to 160 right now. And you'll find our specs everywhere. We've been extremely busy in the last 12 months. We've published 18 specs, which is about, a spec every 3 weeks, I think, basically. For the last 12 months, 4 of them were new. And there's actually even one that we're going to be publishing in the next few days, most likely. So there's a lot of stuff going on. I think as you all are aware, there's a lot of things going on in our industry right now, and it's keeping us standards people pretty busy.
But you didn't say what we've done. You said what we've done, the specs, but what are those specs? What do they consist of?
Well, so those specs consist of cables, connectors, transceivers, form factors, management interfaces, and whatever else we want to go do a spec around. So, thanks for keeping me straight. One other note, we did start off an SFF community. This is brand new as of, I think, a couple months ago. Basically, this community was formed to help drive the promotion, so you wouldn't have to deal with me like trying to promote SFF or some of us individually. So we're trying to actually put some weight behind a marketing around our specs. So you can kind of see some of our near-term work items, but there's a lot more. We're still in startup mode. Come join us. So, okay, now let's get into it. Basic ground rules. Open panel. Please ask questions or offer your own opinions. Some of the topics we do have strong opinions on are 448, which is, in this context, is 448 gigabits per lane. It's not 448 for quad lane or octal lane or et cetera. PCIe 7, E2 form factor, because I know some people are already gearing up for that one. AI needs, we'll talk liquid cooling, we'll talk about John's favorite book this week. And yeah, so let's start.
So I do have a couple of questions I could begin with, but does anybody have a question they'd like to ask about connectors and form factors or whatever? Feel free, anything's free. All right, we got one from Bill here.
Oh, no.
You guys ready?
Hold on.
Will 8639 survive PCIe Gen 6 or Gen 7?
Rock, paper, scissors?
Yeah, rock, paper, scissors.
It's highly unlikely, but it's possible. So to be clear, as a participant in many PCIe form factors, we have acknowledged that it is impossible for them to work at PCIe 5. And once that was done, we argued that it was impossible for them to work at PCIe 6. And we got there. And, you know, PCIe 7's coming, and we're going to have the same debate. And I just don't know anymore. One of the key factors which has actually made the difference in that decision-making is what we're going to accept for the cross-talk mechanisms, the CC-ICN as it's measured now. And as an example, in chem, we restrict that to be on the order of 50 microvolts of noise. And that covers the chem environment pretty well. For many, that tends to live in a much more restricted environment, and we've actually allowed the noise to be larger there. It's actually to get to 6 in the PCIe Mini, the M.2 form factors, you're allowed up to 350 microvolts of noise. So there are actually compromises made to allow the performance at the speed depending on the environment. So, yeah, maybe.
My only comment is just because you can do something doesn't mean you should.
So, Bill, I was about to respond to that, and I was going to say no, next question. But so to answer this question, we're all engineers. We get paid to basically prove people wrong. It's kind of a fringe benefit of our job. So there will be someone that goes and does 8639 with 6.0. There will be someone probably figures out how to do it 7.0. It's should it be done? What's the cost of doing it? Can it be a general purpose implementation or is it a point implementation? All those factors, right? You're figuring out, you're figuring out at 3 sigma, are you going to get this thing to work or is it going to break? How many customer calls are you going to get as a result? So looking at all that stuff, it gets so complicated that I would hope that we do not go down that route going forward. But you know what? Individuals have to make those decisions. So like I said, short answer is no, but someone will do it.
Great question. I had another hand up. Where was it? Come on. All right, here's my question then. You've updated the E1.S spec and the E1.L spec. And in there, you removed the recommended max power from the specifications. Why?
Actually, we're also updating the E3 spec.
I understand that.
So we've had the EDSFF specs now for, 7 years? I think 7 years now. And there was a fight even at that time on what do we specify for power? Do we specify power? What is actually supported? And what we've come to find over the years, or what I've come to find, is that I get questions pretty much all the time as far as the spec can only says 20 watts, so this device can only do up to 20 watts. When in reality, again, engineer trying to prove people wrong, we can figure out things that can go much higher than 20 watts for some of those form factors. I've heard E1.S going above 30 watts. I've heard E1.L going well above 30 watts. It's, and it depends, are you liquid cooling it? Are you air cooling it? Is someone running a hurricane through there? It depends on a lot of those factors. So I had a conversation with several folk, and we all agreed that, this is actually hurting us more than helping, having that informative section in the spec. Because, by the way, this was also informative. So the choice was made to go out and remove that spec. or actually deprecate it, and basically call out the power for the connector itself, which is up to 80 watts. Now, here's the flip side to that. So we recently introduced E2, and I saw an article on it that said, well, E2 is going to run up to 80 watts. I don't see how they're going to cool that thing, which was not the intent of when we did not have the informative power section, because E2 is not, at least, it's, my company's not planning on running it at 80 watts. So it's one of those things where it's like, you're damned if you do, damned if you don't, and it's what will cause the least amount of harm.
And I would give a similar but slightly different story, because I'm opinionated. But one of our major customers tends to live in a world of low flow, airflow, and was willing to support one temperature in power range. And another one of our customers is willing to provide a lot more airflow and a lot more cooling and provide the power. Which one's right? They each have their own requirements. Each of them are valid. And in fact, what we're seeing is an explosion of exactly how we're going to do that. One of the fun new tools we have coming in NVMe is the ability to give a device a power limit that fits in the chassis and system, and the customer will agree to the bandwidth that supports, and all of those decisions are right. The device supports what it's going to support. The host tells it at what power it can run at. What really is the limit there is the testing methodology, which we provided in SFF TWG 123, which gives you a hint about how much you actually have to, what kind of a tornado you need to get to some of the more exotic temperatures and what you can get away with for some of the simpler power levels. And with all of that, you have a cohesive system of figuring out what actually is going to match the device to the need. And the maximum is actually just a distraction, which was telling people that they couldn't do stuff that they could.
Well, I'd also like to add that I think in the discussions that we had in the SFF group was our job is not to dictate what power to run a device at. Our job is to what are the limits that you could run it, the maximum limits. And I think that's where we said, let's take that off of there, because people were taking a informative recommendation and making it policy, which was not the intent from the very beginning. Oh, that was good.
In the back.
All right, in the back. Oh, CJ's got a question back here. It's probably one of mine, too, that I got on here. Go ahead, sir.
Well, just following on the power limits, there's a lot of talk now about people saying, hey, just liquid cool everything, which is not the entire universe, but there are lots that's true in a significant fraction of this server market. So for those present, how much does that guide and drive the kinds of drives that you want to build and the power expectations? And just, I think that's the main question, but piggybacking on that, there are a lot of people that have said, hey, you can go crazy with IOPS, but that's really going to drive up how much power that's going to take to be able to do that. And so people who are, again, worried about that, if an increasing fraction of the world can provide the volumes that it takes to make it still reasonably cost effective to be able to support those high powers, maybe that opens some doors and makes things more interesting.
Somebody should bring a project into SFF. And if you didn't already know, that's currently planned. That was talked about in the last OCP monthly meeting. And it turns out, and it's a useful thing of the one size does not fit all story, that part of what many vendors had been talking about previously before that meeting was a dual-sided cooling, which allows you to cool large area SSDs. And part of what we're seeing is that there is a need for large area SSDs to hit capacity points for nearline storage. And that's not necessarily power hungry, but it sure as heck is capacity hungry. And then there's other compute-driven things which want all the power they can get. And one of the recent observations is that if your area is small enough, as in a E1S or an E1L, you can probably get away with a single-sided cooling plate for at certain levels of cooling. And that's pretty much what's going to be talked about soon in SFF.
And just to educate the people that are here, OCP Storage Project in their last meeting, which is an open meeting, so I can discuss it here, presented ways of looking at E1.S cooling. And there were 3 proposals that came up that were each unique in their own way. And one of the groups in there said, we're going to be bringing something into SNIA SFF to start the discussion. And part of that discussion is, okay, we have 3 different ways to do it. How do we get to one? Because we don't want to build 3 different solutions as we go forward.
Exactly. The last thing you want is 3 different standards on the same thing. So there is a effort before this does come into SFF to combine those ideas all together. And there should be a mail come into the OCP storage mailing list pretty soon to explain that, along with the SFF project proposal, which should be coming very soon.
But I will spit out that one of the other precepts to that is if you do build a device which is liquid cooling capable, it should also be air cooling capable.
Yes.
So that we have a limited number of SKUs, and one size will not necessarily fitting all, will fit a lot.
I would argue out of those 3 proposals, 2 of them are being combined and one is radically different. So.
The third one can be combined. It's a matter of what needs to happen in order to do it. But yeah, it is very different. I was waiting for a question from you, Trent, since
I have
started.
2 questions. One is, I heard a rumor of an E1 that's the length of an E2. I'd like to know if that's factual. The other is, after we had the industry go out and build all these wonderful E3 backplanes with a certain pitch, why would we make E2 be just a tiny bit thicker?
Just to mess with you. No, okay, so let me start with the first one. So the rumor on 200 millimeter E1. So in that same OCP storage call, I believe there was discussion on something in between E1S and E1L. So there's no project work started on that. I have not been informed of any project work starting on that, so I don't know on that one. So I can't speak much more.
Well,
than
but
that.
to be fair, the justification that they proposed in the OCP meeting was E2's too tall.
Yes.
And they wanted something that was not as tall. Okay?
Yes.
But still provided the space to put all the NAND chips.
Exactly.
Right.
Yeah, but part of the question was, why is E2 so different from E3? And the answer is they're designed to hit different needs. One is absolutely intended for a large capacity type structure that is probably going to need a different chassis. And that was part of the problem, is that the E3 didn't support that, even in the long version.
So the funny, I don't know, irony here is that I would call E2 more spiritually akin to E1.L than, and E1.S for that matter, than to E3. It does share the same height, it does share the same location. You could in theory, shove an E3.L. I mean, we talked about this during E3S. You can shove an E1.S into an E3.S chassis if you controlled your Z heights on your PCB. But you could theoretically shove an E3.L PCB into an E2, route out the LEDs and stuff, because everyone loves their LEDs. But you could do that, and it would fit. But that John's answer is 100% accurate, right? There's different usages, and there's one that's driving around the whole nearline SSD idea, which is mostly built around HDD displacement. So that's really what's the driver for that.
Okay. Any other questions? Come on. Connector questions, form factor. All right. There's one. Let me go around here. They told me stay away from the speakers, so.
All right, so with AI driving the need for more performance at a fast cadence, and the power budgets going up correspondingly. You know, how much life do we have left in the 80-watt EDSFF connector maximum before we need, you know, what are we going to do after 80 watts if things keep going like this?
Great. Do you want me to go after it?
I'm opinionated, but I'll wait my turn.
No.
So one of the things which is slightly different in the world is that we're still not calling them GPU centers. We're calling them data centers. And that's because there's a freaking lot of data devices in there. And as you scale out, and perhaps you have 10 GPUs running 600 watts in a server, you're probably going to have many tens of SSDs doing that, and you need to balance that power load. And so in general, because there's an order of magnitude difference, we probably don't get to take 600 watts, even though as a hot rodder, I'd kind of like to.
Okay. I'm going to answer this question. I'm going to catch flack for it. So there is a knob we can turn within the connector, and it's a change. It would be a change to the connector, and a change to the form factor, but it would be backwards compatible, where we can get up to 200 watts. So that change was actually introduced in SFF TA1037, which was the connector for the programmable multipurpose module, PMM, which was SFF TA1034. So we defined a card edge there that basically we figured out how to get 200 watts out of the existing card edge. We have not backported that into the connector spec, and we have not backported it into the 1009 spec, but it is a knob.
And there is a price to be paid for that, of course.
Exactly.
And part of the price that happens when you do that is your cooling becomes much harder. If you were attempting to liquid cool with one side, you might have exceeded that capability. And now you have to liquid cool on both sides, and you've now changed the capacity density equation. And sometimes that could be called for.
Yes.
And it's an interesting world we live in now with all these choices.
Yeah. So, and by the way, I'm not condoning we do it. What I'm saying is that, you know, from the get-go, we've wanted to make sure that the connector was extensible and had options in order to go forward. And there is an option to go forward with it if we did need to get more power out of it. But it's the emergency cord, or the rip cord, basically, you know, in case of emergency, you know, so.
But what's interesting about your question is we have an SSD vendor asking that question to a bunch of SSD people up here in the panel, when in reality, it's the platforms that, you know, figure out what power distributions they want to do. And I'd like to hear anybody from the platform want to talk about future power needs on their part to drive these form factors forward. Because typically, that's the way I see it, is platforms say, this is what we need, go build it, and then out comes E2, right? Very fast, by the way. So who had their hands up? Bill. All right, you get to answer this question. How are we going to drive, and when are we going to drive higher powered form factors for the industry?
So from a platform point of view, we look at several different things. We look at, you know, IOP per watt. We look at, you know, the total amount of power in the system. And what I look at is, if I have an SSD that has a by-4 link on it, how much power do I need to saturate that link? And at PCI Gen 6, I can tell you that number. At PCI Gen 7, I can make a pretty good guess. And it's generally going to be under 80 watts. I do not need, you know, more than 80 watts to saturate a by-4 link at Gen 7 with current flash technology. So that's why, at least, you know, from AMD, and I used to be at Dell, I was a platform architect at Dell. You know, we didn't jump up and down. But the thing that does drive us nuts is the fact that, you know, once we get over 30 watts or so, air cooling becomes extremely difficult for SSDs. Now we have to figure out a different way of cooling them. And I'm right there with the SSD vendors, I don't want 6 different ways of cooling an SSD. I'd like one. And, what do we need to do to the SSD form factor spec to make those devices capable? And, given that I'm only looking to saturate that by 4 link, what do I need to do at 35, 40 watts? Single-sided cooling solutions are probably okay, given up to about PCI Gen 7. If you go above that, I don't know, we may have to go dual-sided, we may have to, do some other thing. The other one you have to look at is what is the fluid temperature coming in, is it, 20 degrees C, 30 degrees C, 40 degrees C? That's another one that kind of pushes you towards single or dual-sided cooling methods. So at least from AMD's point of view, we would like to stay with single-sided. Putting in dual-sided cooling for an SSD is a lot of infrastructure that we really don't want to have to do. So.
Yeah, and you bring up a point. During that discussion in OCP, it was made clear that hot plug was still an important thing, and the more things you have in there, the harder it is to hot plug.
I was going to ask about hot plug.
Well, you brought up my question that I had on my sheet, so we're even now, right? Oh, here.
I'll just expand that. It seems like we want to get a nice roadmap that shows how much cooling can you get for each form factor with one-sided cold plate, with two-sided, and actually with integrated liquid as well, with a blind quick disconnect. And how scared are we about that last one?
Very scared. Very scared.
But I will note that I've heard, not my opinion, but other opinions, that SFF TA 1023 was a great advance in the ability to estimate what you can get out of air cooling for a given device. I've also heard complaints that that methodology was completely unreasonable. Those are two opinions. Those are okay. When we come into how we actually define that, I would say that I hope we're going to come up with a similar document, which is going to tell us about the fluid dynamics which are necessary and the fluid properties which are necessary to make these single plate or dual plate work, and how you actually have a single test method to at least have the same language about what your cooling capabilities are in a cold plate system.
And are there, can I just follow up on that so I can get the mic away? It seems like there are opportunities to research the materials there, particularly with a view to what the impact is going to be on your pitch, right? So that you don't get too big and still be able to, do the hot plug of being able to pull things out of there. I think that's all going to
I
get
think
very
some
interesting.
people want Caltran 25. Some people want absinthe.
CJ, I wanted to respond to your comment about, is there a path to putting quick connects onto the SSD? One of the biggest, scariest things from an SSD supplier perspective is that, okay, what happens if the SSD leaks? I personally don't want to be at fault for that. So I would like to have, one of the things that we talked about in the OCP storage meeting was that, the common solution right now for E1.S, we were talking about being, host owned cold plate, right? And so we're just defining effectively the interoperability between the device itself and what surfaces it needs and edges and stuff, and then where the cold plate would be located in the system, but the system owns the cold plate. So I'm hoping we don't have to go down the world of quick connects and connecting in fluid. But never say never, right? So I want to say no because it's scary, it leaks are bad, and Reminds me of a
But certainly the size of the cold plate is not necessarily understood at this point either.
That's true too.
So we are taking turns in this questioner walking around with the mic. So we're open for more unless you, yes, sir.
I've got a question.
In the front.
Okay, so Michael previously brought up, how far is the connector, is the connector extendable because of the power? And the bigger question in my mind is the signal integrity, because, we're going to be working on PCIe 7 at some point pretty soon. And then PCIe 8 is announced by PCI SEG, And then, there's probably something after that.
Yep.
And so how many generations is the connector going to survive?
Yep.
And what does topologies look like? Because this is going to become a bigger system question for all of us coming up very, sooner than we probably want to be thinking about. So, and I think so Michael, I think that's the more important question is when does the connector break due to signaling and not due to the power? Because I think we can get the power out of it. It's the signaling event that's really I think the bigger problem.
So one of and here I am answering questions out when I'm actually looking for others, but one of the things to look at, which is interesting in my not so humble opinion, is the SFF TWG 1044 and 1045 hybrid connectors, which are allowing a straight path for cabling for the high-speed signaling and a mid-plane connection for all of the sideband signals and power delivery. And that basically enables some server construction methods, many of which are being used today, but it basically allows the orthogonal connectors to actually not be orthogonal in signal integrity flow. And they can actually be straight in that kind of connectivity flow. And that's a really interesting solution to help some of the existing. So does that necessarily marry with today's SAS and SATA and U.2 implementations? It's not really intended for that, but it does extend the 1002 life. Okay, Bill.
Since you are the transceivers group too,
Yes.
when do you guys see PCIe and like the 448 gig stuff collapsing into one common PHY?
Oh, that is a great question. Because PCIe, in theory, if you were to follow history, and this is not a PCI SIG message, but if you were to follow history, then the PCIe after 8 would be 512 and not 400 or 448. So would those be one PHY? Would they follow common forward error correction and modulation levels and all that fun stuff? That is a great question. I do not know off the top of my head.
Well, I will note that SFF has already given a report to PCI SIG about lessons learned at 200.
That is true. Yeah, it's hard. I mean, this 400's even tricky right now. I mean, we're trying to get stuff kicked off. Right now we've got, 1043, copper connections for AI, right? Will copper work at 448? And what do those topologies look like? So.
Yeah, 2 inches.
All right. Any more questions?
Up, front row.
Trent.
Just an oddball question with speeds going up and everything and everyone wanting more drives attached. Do you see any future to optical connections to SSDs?
Go ahead.
So are you saying the optical directly into the SSD itself or to the connector to the SSD? Into the SSD. Okay.
So
Go ahead.
So I see it's going to be a stepping stone, right? I think the first implementations we'll see will be optical with the conversion in the connector itself. And this is how we extend 1002, by the way, is basically you get the connector, you get your optical to copper translation in the cable, and then you got copper from the SSD ASIC to basically the connector. And so that's how you extend the life of it. At some point, that might become too difficult. And that's where we need to start talking about what's after 1002. Which is kind of went back to what I was saying earlier, is that there's going to be a cliff at some point. It's just, similar to what we talked about at 8639 at the very beginning of this, right? There's going to be a cliff where it gets too expensive or too difficult to go and do it. So.
Also, there's when you hit that cliff and let's say you do transition, you just can't cut off a connector or a form factor, right? Some of our customers say, you need to deliver that SSD for a while because I got to, fill in for spares and whatnot. So you just to transition it to SSD vendors, that's just another SKU, right? And then we'd have to build one for that. So that's a hard problem as well, and just from a materials point of view.
One of the projects that Kioxia built and POC'd, and we wrote specs around, is the native NVMe OF device specification. It is a SNIA spec you can look up. And among the things that we learned is that when it came to adding on an additional controller, most everybody who wanted to pay for storage did not want to pay for an extra controller. So when optical is a more common die connection, it can find its way in, but probably not till then. It won't make economic sense. Okay, we're looking for more questions. If not, we're going to have to turn Mike back on.
Do you guys really want to hear John sing? Is that what I'm hearing right now?
And dance. We hit your questions.
You have any others?
We could talk
I think
single count. Why don't we talk sidebands?
One of the fun things that's happening today in SFF is the sheer number of high-speed cable connections for different mechanisms and different servers which are currently being contemplated. It is actually getting to be quite impressive as a body of work on its own. You not only have the PCIe copper link, but you have a whole new series of things, including a new set of front panel connectors to allow another type of building. And there's a whole nother need coming for root-to-root ports in cables, as in the external cables, in the different mechanisms you're interested in there. And so there's a lot of busy work that the connector companies keep bringing into SFF for more and more types of PCIe high-speed links. And those different use cases are actually what are driving those.
Okay, I'm going to bring up a question to the audience, as well as to some of us that actually, John, you and I were talking about this, I think about an hour or two ago. So one of the downsides that we've had with the connector, the EDSFF connector, was the amount of sidebands we have on the connector. We didn't have that many extra reserve pins to begin with. I think we're down to one. And the question is that what are the needs to future sidebands? And what are the things that we may need to cover? Because that has been one of our limitations. And, it's good to a certain extent because it helps us be more disciplined in what we add. But, if people are seeing additional needs, we need to start having these discussions because we need to start figuring out how we're going to solve some of those problems.
So a question for the audience. So among the things that are happening in the world right now, are an explosion of needs in management. And I confess, I did not mention that another one of my side jobs is helping to co-chair the NVMe MI Management Interface Group. We're looking at things like security needs for attestation in a post-quantum crypto world where we want to be aware of every device. And we've now actually built into, as of 6.4 and 7.0, that we now have a mechanism in PCIe to quarantine a device which has not passed attestation. So systems now have the power to really control what devices are in and whether or not they trust them in their environment. So those sorts of high bandwidth needs are being asked for in a two-wire interface of some kind so that the system gets to be more secure in its boot process. And that whole boot process is not expected to go on for minutes. The entire server is expected to finish in seconds. But that's a lot of data moving around, and we are not talking about your grandfather's SM bus anymore. Once you have something that fast, you can start using it for some of the other signaling purposes, should we decide to go down that road. Any thoughts from system houses and in general? Bill's comment bears repeating that management is pretty much a pain in the butt. For SM Bus and I3C, if you're not aware, we've actually built in high availability requirements into NVMe, not requirements, options into NVMe MI, so that when your SM Bus goes down, you actually have another endpoint. You can go say, what's happening over there? You need some help? You need to be reset? And you can still have the ability to send off our advanced notices of things going wrong or critical temperatures or other issues from one of the available endpoints.
Okay, question to the audience. Oh, there we go.
So one of the things that I think has been lacking in the industry for a long time is the lack of channel reference models. So if you go back to PCIe, when NVMe came out and all of a sudden we're using PCIe as a storage device, the channel models for storage are radically different than a CHEM add-in card. And historically, PCIe never got off that model. It was CPU through the board to a connector, and you plug in a CHEM card, and that's all they did. The fact that we're doing PCIe with storage, we're now looking at 448, and it seems like to me SFF is the ideal place to do these reference architectures, because you guys, the bulk of the effect of the reference architecture is on the cables and connectors and all of that. And the guys who develop silicon, like AMD, we develop a PHY to go drive that thing, but we don't know what's out there. So I think it'd be a great place to sort of aggregate all this knowledge of what you guys have and start putting out some reference architectures, because, like you said, at 448 gig, what's that channel going to look like? How long of a cable can I drive? How much etch can I drive?
Well, so SFF TA 1043, which is our copper connections for AI, there are going to be reference channels for it, but that's on the transceiver side. And I think I like where you're going, and maybe we need a similar project on the PCIe side, because as you look towards this, because from a storage vendor perspective, I'm designing, from connector to, to my controller. and the connector guys are doing, just the connector, or maybe they're doing out to the cable. But no one's looking at from here to the connector itself. And so that would actually be really awesome to have a project like that in SFF, where we can have this repository of channel models, similar to repositories that like IEEE have had and other places. I think it's a great idea, especially since storage is a pain in the butt in terms of, topologies. So
we actually have opened up a project to support 448 Ethernet. And that has interesting properties in that some of those folks want their channels to remain hidden but available under certain circumstances to certain people to run their simulations, and some just to be open. And I can imagine the same thing in the PCIe SIG world.
Yeah, because, in the days of AI, you're not just designing a server anymore. You're designing racks full of servers and, getting stuff from A to B. What do those models look like? How much flexibility do I have?
And everyone disaggregates in different areas.
Exactly.
Bill, you get a gold star today. Good job. That's a worthwhile project. We need to start looking at how to do that, because with PCIe 7 work that's going to start up at any point, we need to have that conversation. I think it's a good one. Yeah.
So we are down to our last 5 minutes. You need to get your questions now or hold them till next year.
And actually, general question to the audience. Where do we suck? What do we need to go fix? What do we need to go and demystify or whatever? Because not only talking from the technical working group, but even from the community perspective, like how can we help educate you guys better? Do we have to do something with stuff like labels? Do we have to do something with other stuff to kind of decode what certain things mean? I know we have alphabet soup in terms of our specs are concerned, but what do we need to do better?
I know it's a minor complaint, but I do think we need to improve the LED indicators. There's differences between the E1, the E3. We don't necessarily provide the information that's required for some of the use cases, especially in these high-density environments. We should probably look at some of the work that Vita did in this space. That would be my comment.
Okay, that's a good one.
Where are you from?
What company? I'm EDSFF. I'm Huawei Canada.
Oh, okay.
So Huawei these days, yep.
Wow.
Okay, and yes, and there's lots of fun stuff, including the CXL from JEDEC, which has its own new white LED. And it's fun if you had listened to the usability standards and how every vendor had a different solution.
The white LED's been in there since day one.
What was that,
And
Bill?
the agreement on what it meant actually took day 765.
Hold on, what was the comment from Bill?
The
Oh,
white LED's been in there from day one.
He is somewhat right on that one. He's half right. It was in 1008. We never defined it in the pin signal spec.
Oh.
You lost your gold
Yeah.
star.
well, you still get 4 points.
Yes. Yes. Valid attempt.
All right. All right, well, then, any more? Or we can let the next group get set up.
Thanks, everyone, for participating.
Thank you. Thank
Appreciate
you.
it.
Thanks for the questions.